This is the United States Energy Association Power Sector Podcast. I'm your host, Herman K. Trabish. I've covered the power sector since 2006, and I currently report for Utility Dive. My guest today is Xcel Energy's Senior Vice President for Systems Strategy and Chief Planning Officer, Alice Jackson. As head of Xcel Colorado, Alice brokered groundbreaking agreements between Xcel Energy and advocates for distributed energy resources, or DER. In her current job, she is leading Xcel planning to reduce carbon emissions by developing new resources, new technologies, and integrating DER into its power mix. While the nation anxiously awaits tomorrow's release of what Paul McCartney called the last Beatles song, we are going to talk today about plans by one of the biggest electric utilities in the U.S. to meet the Biden administration goal of a 100% clean electric power system by 2035 and Xcel's goals of an 80% carbon emissions reduction across the company by 2030 and a 100% reduction by 2050. Alice, those climate goals require major reductions in carbon emissions. Can you briefly describe how comprehensive system planning allows Xcel to meet those goals over time by incrementally replacing traditional resources like coal and natural gas with new utility scale and distributed clean energy resources, and how you plan all that out?
Absolutely. But first off, I want to just say thank you very much for having me today, Herman. It is a pleasure to be able to speak with you again, as well as to speak with the United States Energy Association on these important topics. I think that first off, it is important to recognize that the energy transition will impact all areas of energy infrastructure, not just the generation aspects of our business, but also the transmission and the distribution. And when you think about things like home heating shifts, the natural gas system that provides home heating opportunities, as well as industry-wide elements for manufacturing and others, is going to be an important piece of the conversation as well. When I think about the energy transition, a very balanced and deliberate approach is going to be necessary in order to be able to meet the needs of our customers, to ensure the ongoing reliability, and to focus centrally on the affordability of energy to our customers moving forward as well. And that means that we're going to have to bring some pragmatism to how we're making this energy transition. It's been such a pleasure to work at Xcel Energy. We were the first utility in the nation to announce a zero carbon system by 2050 with the important guardrail and guidance that you just mentioned, which is the 80% carbon reduction, or at least an 80% carbon reduction by 2030 across all 8 of the states that we have the pleasure to serve. Figuring out what these plans look like and building on them has been a cornerstone of the activities that we've undertaken over the past several years and will be going forward. I think you're familiar with the steel for fuel strategy that we came up with and looking at how do we transition and balance the costs for our customers while adding significant volumes of wind energy to our systems. And we've been able to do that and saved our customers millions, if not billions of dollars in fuel costs as we've added these resources to our system pragmatically, reasonably, and we've learned more about them. So as we move forward through time, yes, we're going to continue to replace our generation assets such as coal and some of our natural gas facilities. And what we're seeing is that what this is comprised of is a significant amount of wind, solar, and battery storage. But that's not just on the big transmission system and the big towers that everybody sees out there. It's also finding solutions in people's backyards and working with our customers on that distribution system as well. And those are the distributed energy resources that you were mentioning that will be a big part of this clean energy transition as well.
Right. And so Xcel's policies call for an increasing role for customer-owned DER and a reduced role for natural gas to meet demand spikes at the distribution system, the customer level. But some people say that DER simply are not reliable enough to replace natural gas. Could you tell us the role of advanced power system control technologies like distributed energy resources management systems, also called DERMS, and why they are needed? More specifically, how can Xcel system operators use DERMS and sophisticated data analytics to make DER flexibility an effective tool for meeting reliability needs? And you may want to break that down. You may want to talk about DERMS first and data analytics second, because they work together, but they're separate. And I don't want anybody to conflate them.
No, I think it's an excellent question. And I think the important piece of the puzzle here to point out first off is the advancement in technology. This is really time moving forward and helping us figure out to solve the problem of getting to a zero carbon system. If you can imagine stepping back 20 years ago, these software technologies, visibility and communications technologies were not available for us to be able to make the advancements in the things we're looking at today. So think about your home. And if you're sitting there and you have your programmable thermostats today, thanks to the Nest thermostats or the Honeywell EcoBees, and all of those different technologies that are out there, we have a lot more opportunity to engage with our customers on how they're using energy versus what it was before was essentially blind, right? As an individual customer would use their systems, you really wouldn't see what they were doing until it was aggregated up at a larger level on your distribution network, whether that's in a substation or even upstream from that. So when we continue to look at the energy transition and how can we best optimize where we're investing in generation resources, cost is a huge piece of this. So we've always said affordability and reliability. We have to maintain the system so that it's not operating less than what customers have enjoyed to date. But then also, how do we make it the least cost or an affordable system for us to move forward providing services for our customers? When we can work with our customers and how they use energy from our system, that helps us better align those hours that you're running your air conditioner or charging your electric vehicle or running your dishwasher with the hours that we have clean energy available. And that means less infrastructure has to be built, less capital has to be expended on the system, and lower bills for our customers at the end of the day. So a distributed energy resource management system helps with the symbiotic relationship and looking at how those utilization of the system by the customer can balance with the operations that we have to bring for reliability to the system. That visibility then gives us the opportunity to communicate with customer devices that they have connected to the system, whether those are thermostats in their homes, they're the EV chargers that they have plugged into their cars, in order to balance out the network, in order to make sure that the electricity can flow where it needs to go, it gets there when customers want it there, and it's increasingly clean on the system. When you talk about how to do this with the data analytics, we've measured how customers use energy over the past several decades. And we're getting more refined in being able to see how customers are using that data on a regular basis, thanks to things like the intelligent metering that we have on the system, as well as those smart thermostats, right? And so being able to do that, we can then look and we can predict patterns and align those better when solar energy is available. But the sun doesn't always shine without clouds, Herman. Sometimes those clouds come across and it changes the amount of energy we're going to get from a solar resource. At those points in time, we may want to scale back how somebody is charging their electric vehicle, for instance, because that is the time when we don't have as much clean energy and it needs to be used somewhere else for another process that is a higher priority for the system or for customers. And so having that relationship where you can communicate and see that real time is a real advantage for being able to drive affordability into the way that we are doing the energy transition. That DERMS system, though, has to connect with other systems inside of the utility as well. So I think you and I have previously talked about energy management systems, which is kind of the master scheduler that tells when our generation at the largest scale needs to be producing energy versus not. And so the visibility for our operators into the DERMS, it combines with that energy management system known as the EMS in order to be able to provide a reliable output. So the analytics between the two, the visibility is key on a real-time basis so that we know what is available to be called on. This is particularly important as we move into like inclement weather situations. We have the pleasure of serving customers that range from almost the borders of the US from Canada all the way down to the southern borders of the US and Mexico. We have high altitude customers, we have cold weather customers. And so being able to provide resources and the energy that these customers need in all of the climate situations is important. These advancements in technology give us more capabilities to see what is out there, to balance the system and to integrate more clean energy onto the system, whether that's a renewable resource like wind and solar, or it might be a geothermal or a long duration battery storage or clean hydrogen. So going forward through time, this is going to evolve. but these software and technology tools are going to be an important piece of the puzzle as well.
Alice, I just want to say that I'm glad you're in charge of that, and I'm not. Um, it's something. Once again, it's going to be incremental. It's going to be over time, and it's going to be integrating increasingly advanced approaches. And what that means is there's a planning process. What is the timeline for your planning process? And you mentioned cost. Are you confident that the cost of making these changes, the impact on Xcel customers, it will be uh, less than it would be if you were continuing your reliance on natural gas?
Yeah, so I think a couple of things there is, first off, the planning process is not just a one and done, right? We have to continuously look at the evolution of the system. Our customers are choosing different technologies. We think back into the 1970s with the advent of air conditioning really spreading across the country. That was a huge shift in how customers used energy and what utilities had to react and build resources in order to be able to solve for providing the energy that they were looking for. We're now facing, consumers taking a look at how are they going to have their home heating be served, whether that's from heat pumps on the electric side, or if it's a heat pump backed up by natural gas, or some other mixture. People are looking at electrifying their transportation, their automobiles, and choosing when to charge those. Some people work the night shift and charge during the day. Other people typically, go to the office during the day and they charge their vehicles at night. So there's different ways that people are going to continue to use this system. We use the predictive analytics to sit down and look at the probabilities of what does this system need to look like over time. And we're looking at that now. And really, we're looking all the way out to 2050 right now, because with the dramatic changes that we're looking at, that is going to substantiate some significant changes on our distribution system. I think there's a really good study that we look at of, okay, how big of a difference is this going to be? And McKinsey did an analysis back in the day that looked at, if we achieve the zero carbon system by 2050, how much more reliance are we going to have on the energy coming from the electric system, the pipes and the wires that we see outside our doors, now versus in 2050? Today, they estimate that national consumption of energy is around 22% in the energy industry across the electric infrastructure. By 2050, at achieving a zero carbon system and maintaining the 1.5 degree C scenario, they expect it to be a 76%. That means there's a pretty big shift that's happening on our energy infrastructure across the country. So when we approach the planning process and the infrastructure that we build has 40, 50, 60-year lives associated with it, we have to make decisions very early on whenever we're building new or replacing and maintaining things on our system. So that planning process is underway right now, and that will shift into implementation as we move forward through time. But you will continuously look at it because new technologies will come along. It'll be different than we exactly expect, but it's the right direction for us to move. Then you come back around to affordability and what this is going to look like. What I will tell you is that I don't look so much as, is this a natural gas-based system or not? Natural gas is going to remain an important component of our systems to provide for reliable and low-cost energy for our customers for quite a long time. Particularly, like I was mentioning, since we serve high altitude and cold weather climates across our jurisdictions. The solutions are going to include that natural gas, but it's at a decreasing amount inside of what we're doing. And so that's a mixture of how are we going to meet the needs of the system. You can see that in the electric resource plan that's ongoing in Colorado right now, that's pending the regulatory commission's approval. And the transition there is we do have to continue to add, and in that instance, we're recommending about 600 megawatts of combustion turbines. And those combustion turbines, though, won't operate very much, but they are needed at critical junctures as an insurance policy for our customers. In those coldest winter days, if you don't have those assets, you may not have electricity when you need it to keep your household warm. And so those are essential components to come on the system and provide energy for our customers at critical times. And that's why they are still needed, and that's why they're essential to providing reliable and cost-effective service. When it comes back to affordability of the overall picture, We look at the energy transition. It is something that is necessary for our customers from a climate perspective, from a sustainability perspective, and from a reliability perspective long term. This is something that is the generational question of our lifetime on how do we continue to provide the energy our customers need at an affordable cost, but that's increasingly clean. And we believe that we can do this in an affordable manner. Another study that I'll point you to is one that was recently published by Edison International. And they were looking at their system and going, what does the transition look like for them through 2050 as well? And what they published is that they're looking at the analysis and they're saying that energy costs for a household will actually decrease about 40%. Now recognize that's not the electricity bill. That is actually the total cost of energy from gasoline to home heating to home cooling and all of those different activities. So there is the real potential as we move forward through time that we're actually saving households money as we move forward and we implement sustainable, clean, affordable, and reliable energy for all of our customers across our systems.
Wow. Yeah, I can see that. There's a lot of uncertainty going forward, but over time, when we're starting to have a clear picture of what our goals are, we had hoped to set aside some time for having a conversation about political, regulatory, economic, technology variables. Can I narrow that, Alice, just to take a few seconds really, and tell me, is one of your key regulatory concerns getting your regulators to understand your need for what you spend money on now so that you can make things work in the future? Would you say that's a key regulatory concern?
I think more what I would say is a key regulatory, and I think it applies to the legislative process as well as a little bit of patience. We are moving into an area of uncertainty, as you just mentioned, and that's going to take a lot of different steps of analyses that we haven't done as extensively in the past. We've already seen a dramatic change in the way that we model our systems and the frequency that we have to look at things. We moved from looking at 1 hour a year when customers would peak and use the energy, so like the hottest day of the year, typically with all the air conditioning running. So now we look at every single hour of the year with the types of resources we're bringing to the table. So looking also then at like the entire distribution network that our customers have their homes plugged into, that is a different step in analysis than we've done ever before whenever it comes to this large scale planning. So a little bit of understanding of the technology is going to cost more, whether that is the software components of it or it's the replacement of the hardware, but also can provide significant benefits. We need some of the patience in order to be able to do the right analysis, to bring that forward for conversations and input from our customers, our stakeholders, our regulators, and all the others that are really interested in how we're moving forward. And that's really the exciting piece of the puzzle we're in right now, Herman. There is so much happening that is exciting in this energy industry and the technologies that are coming forward to help us make it possible and the costs associated with those coming down. The Inflation Reduction Act helped with saving our customers money. The dollars that were approved and just handed out as part of the DOE funding for the different technologies and what we're researching, we are really on the front steps of watching the energy transition and being in the middle of it, quite frankly, and what it is to look like to be able to deliver this valuable, life-sustaining resource to our customers in an increasingly clean manner. It's an exciting time.
Yeah, it's very exciting. Alice, I want to thank you very much. You're one of the utility industry leaders in renewing the nation's power system. I've watched you move through this process for some years, and you're just getting started. Thank you so much for coming on. I want to thank everybody who took the time to check out the USEA Power Sector Podcast today. Don't forget to tell everybody you know about our quest for energy transition solutions.